All right, let's do section 9.3, page 461, number 9, which says, show that x squared grows at the same rate as x squared plus 4x. So I'm going to start by letting g of x be equal to x squared and f of x being equal to x squared plus 4x. Now in this section we learned that if two functions grow at the same rate, then in the limit as x goes to infinity, f of x over g of x will be equal to some constant L, which is not equal to 0. So the way to approach this problem is to find this limit and then see what it's equal to. So we're going to take the limit as x goes to infinity of f of x over g of x, and let's substitute in here. So I'm going to have the limit as x goes to infinity of x squared plus 4x over x squared. Now there's a lot of algebra that I can do here before I have to substitute in my limit. So I'm going to have the limit as x goes to infinity. I'm going to start by breaking this up. So I'm going to have x squared over x squared plus 4x over x squared. And now I can do some canceling. So I'm going to have the limit as x goes to infinity of 1 plus 4 over x. Now I can substitute in. And when I substitute in, I'm going to get 1 plus 4 over infinity. And 4 over infinity is going to give me 0. So I'm going to end up with my limit being equal to 1. And this is a non-zero constant, which means I've satisfied my criteria up here. And that tells me that x squared grows at the same rate as x squared plus 4x. And this actually brings us back to the end behavior model that we talked about way back when we did limits at the beginning of the year. And the end behavior model for x squared is going to be x squared, and the end behavior model for x squared plus 4x is going to be x squared as well. So these two functions have the same end behavior model, and they also grow at the same rate.